Lesson 1.2 is split up into 3 different sections. In the first section, we'll look at different types of transformations. The definition of a transformation is just the moving of a parent function. A translation will shift every point in the original function the same distance and direction. If you have a vertical shift in your function, it can go up or down. And the vertical shift function would be g of x is equal to f of x plus k. F of x would be your original function, or your parent function. K is going to be the shift up or down. And then g of x is your new function. So that's a lot of information to write in there. Make sure you have all of this written down before you watch the example on the right. It says compare the graphs of y equals x squared and y equals x squared minus 3 and describe the transformation. Taking a look at these two functions, y equals x squared would be the function in blue. That's this graph right here. And that would be the parent function. Notice y equals x squared minus 3 is down further. That's the function in red. Y equals x squared minus 3. It says describe the transformations. Well, if we look at it, it looks like everything just moved down 3 units. That would be a way to describe it. So it has a vertical shift, down 3 units. Now if we take a look at the original graph, x and y for the parent function, we have 0, 0 as our vertex. That would be this point right here. In the new graph, if we keep x the same, our output translates down 3 units to negative 3. If I look at that point on the top left, negative 2, 4, that's on the parent function. Notice that point translates down to negative 2, 1. It's just the output moved down 3 units. And if I look at that point on the right, 2, 4, up here kind of by my equation, notice the 2 stays the same, but it only went to positive 1 in my new function. Taking a look at those ordered pairs, we have our original graph and our new graph. So that would be f of x, whoops, sorry, write that again. Our new graph is g of x. It equals the parent function f of x minus 3. It just moved down 3. And f of x is x squared, and notice it's x squared in both of our equations. Let's try another one. For our next example, please change the g of x function in the equation to x minus 3 squared instead of x plus 3. Otherwise, the picture doesn't match, and then that's not good. Taking a look at a horizontal shift. A horizontal shift will move your graph from the parent function left or right. And what makes this type of shift unique is it always goes in the opposite direction. So that's something that we have to think about. Oh golly, I just ran into that space right there. When we do a horizontal shift. The definition would be our new function is a transformation of the original function. And now we're going to use the letter h to represent the direction. That means that f of x is the original function. In our case, it's a parabola again. H is the shift left or right. And then g of x is the new function. Let's take a look at our picture. It says compare the graphs of f of x equals x squared and g of x equals x minus 3 squared and describe the transformation. In our original function f of x, the vertex is at 0, 0. As we look to where g of x is located, the vertex translates 3 units to the right to 3, 0. Take a look at -2, 4. That's one of the points plotted on the original parent function over here on the left. And that moves over to +1, 4. So notice we're adding 3 to our inputs to move it 3 to the right. But in our equation, it's minus. So that's kind of an interesting change right there. So it moves 3 units to the right. That would be a description for the fact that g of x is the translation of f of x minus 3 in this equation. So the x minus 3 is moving it 3 to the right. For the original parent function, f of x equals x squared. A reflection maps each point over a line. And a reflection is going to deal with a negative sign. If you're reflecting something over the x-axis, that would be the horizontal boundary line, what you're going to do is change the value of your y coordinate to negative, or whatever the opposite sign is. So you're going to change y to the opposite sign. The notation would be g of x is equal to negative on the outside, f of x. That means you're changing the sign of your outputs, and that would be your y value. So let's take a look at this in action. It says graph f of x equals 2x minus 6, and then we'll graph negative f of x, which equals negative 2x minus 6. Let's graph f of x first, 2x minus 6. That will be our start function. Go ahead and pick points or use the slope and intercept to draw that line all the way through the graph from edge to edge. There's my graph of f of x equals 2x minus 6. I plotted several points on my coordinate system, and I picked 3 of those points for my table. My x for my input and my y for my output. Now, if I want to describe or do the transformation for the negative f of x, or reflecting over the x-axis, I'm going to take all my y values and switch their signs. My first order pair was 0, negative 6. Now it will become 0, positive 6. My second order pair that I used was 2, negative 2, and now my output becomes positive. And my third order pair would be negative 1, positive 8. Watch the reflection happen as I plot those new points. 0, 6, 2, 2, negative 1, 8, way up like so. If I connect those 3 points and go all the way through the line, I will have reflected over the x-axis. Well, it is a reflection. My line wasn't working very well for me when I tried to draw that in, so hopefully yours looks a little bit better than that. If we look at our original function, f of x equals 2x squared, or 2x minus 6, and negative f of x, we've done the reflection over the x-axis. One final translation, reflecting across the y-axis. Now, like reflecting across the x-axis when we made the y-coordinate negative, if we reflect across the y-axis, we simply make the x-coordinate negative. And this can get a little tricky looking on your picture, but when we're done, we should have a reflection over the y-axis. It says graph f of x equals 2x minus 6, and f of negative x equals 2 times negative x minus 6, and describe the transformation. Once again, let's graph f of x first. There's our original parent function for this translation. Now, the definition for reflecting across the y-axis is we're going to change the sign for all of our x-coordinates. So now the x values will change, but the y values will stay the same. The unique thing about 0 is it's going to stay 0, and that's right on the y-axis. Positive 2, negative 2 will go to negative 2, negative 2. Negative 1, negative 8 will go to positive 1, negative 8. When we plot these 3 points, notice 0, negative 6 stays the same. Negative 2, negative 2 goes over to the left. Positive 1, negative 8 goes to the right. Go ahead and connect those 3 points. Once connected, those are the reflection over the line, or over the y-axis. In class, we'll work on those practice problems down below.